Namaskar. We are back with another episode of Career Corner. As you know, every time, every day, we focus on one domain of learning and we bring a guru from that domain to speak about that domain, its evolution, its features, its challenges of the moment, and how that particular domain is learned on the campus of Adamas University, Kolkata. Today, we have someone truly in the spirit of the word guru, truly a guru of sciences. School of Basic and Applied Sciences, SOBAS. We will talk to Professor Dr. Bimal Kumar Sarkar, who is the Dean of this particular school, on how sciences have evolved throughout the journey of civilization, what are the challenges before sciences today, how 21st century has marked a departure from earlier study or learning of sciences, what is the research environment today in India and particularly in his department, in his school, and how the school is gearing up to the 21st century knowledge society needs with respect to basic and applied sciences. So, thank you for coming and giving your time, Dr. Bimal Sarkar. We were expecting to have this interview for quite some time. Now that you are here with us, we are very happy. Dr. Sarkar, let's begin by telling what has been the role of, if everyone knows that there is no life without science and there is no science without life as well. But what has been the focus or the role of sciences through civilization as the civilization has grown through phases, and how sciences has evolved from the earliest point when sciences were learned to today as the 21st century is now on, 2 decades are down. So over to you, Dr. Sarkar, to give a note on the evolution of sciences with respect to mankind.
Thank you, Professor Chowdhury, that today is here the good opportunity for me that to express some words regarding science in the human civilization. Well, if we see the very beginning of the human civilization, then science is not new. It comes from the necessity of the human civilization. If we see very early point of civilization, when human being comes and start to their livelihood here, then first they start to think what is this energy, this sun, this air, this water. So it comes from the survival for themselves, how to survive. They start to think how make the life very comfortable, very adaptable. Then they start to explore many things. I should not say that it is a discovery, rather it is a review, because nature given everything to us only to explore the things which is available in nature. Just this thing was explored by human being. Obviously, it starts from their requirement. When they see that they have to fight against animals, they start to think how the stone gave the conformation weapon. They start to think this and use this against the human, against the animal for their survival. They explore that special shape of stone gave this facility to them. They then started the production of weapon. They started their food. They started how to manage for the cultivation in the field. They started the exploration of finding food. Then they think that they have to be safe against the natural calamity. For example, they have to survive from different type of inconvenience environment which is imposed on them. Then they started the facilitation of such kind of environment and comfortability also. They started making the dwell, making the village, everything comes. So, if we see this history of human civilization, then science started from the same point of time when human civilization started. So, science is not that I should say it is one kind of very bookly included some information, but rather it was there and human being started to explore them. So, science is very natural. So, it does not need to give the knowledge from the different part of the places. It started from the requirement of human civilization. So, science comes in this way. Then if we see the human civilization evolution, then as per the requirement of human civilization, then the science getting the evolution and it goes through the evolutionary process, and as per the requirement, time to time the variation, science becomes also evaluated. So, then we can find that science always going on some evolution process. Now, question comes whether the science is theoretical or application based. One thing is very important point, I should say science started from application based, and to give the confirmation to a proper way, then theoretical aspect comes to explain those things. Then human beings started to think that what we see around us is nothing but two things. One is matter and other is energy. Only thing is that how to utilize this combination of matter and energy. Then they started to give the new formation of application based science, obviously supported by then theoretical aspect, thinking behind this should come there also. So, then science just going on day by day and year by year, the science comes today as we are seeing around us. So, in this way science is always getting evolution, and today if we see from beginning of our daily life to the bedtime, each and every aspect is the fruit of science. If we talk about our daily commodities, we see that this is a product of science. Then we started our life through different activity. Everywhere we see that the product is from science. When we go to bed, and then also we see that it also comes to the end with the help of science. So, everywhere without science we cannot think our daily life also. So, science is very important. Here I should express science not in a simply very confined word. It is the broad sense, actually the basic and applied sciences. So, in this way comes the concept of basic and applied sciences. So, if one does not know the,
that's very interesting, sir, because a lot of use of science today is on the understanding of applied sciences. The fundamental science growth is also required because human civilization grows or evolves in knowledge, perception, wisdom through basic sciences, the evolution of basic sciences, but applied sciences is what makes a difference in day-to-day life. So, if you could also explain how applied sciences have evolved over time, and how basic and applied sciences today are coexisting and contributing to the growth of civilization.
Very relevant and very interesting question also. Already I told that most probably science comes very initially from application based, because when just human beings start to think that how we can make our life very comfortable, then they started to apply different even though that time the principles were not known to them, but by their experience very empirically they start to apply the different domain of science, right from their taking food to bed. Next comes that to know about the inherent processes behind this application, how it going on. Then people start to think how to improve this, how to more enhance the field of application science. They started work, then theoretical aspect comes, basic science comes. So, nowadays what we see, it is basically, it was there also in ancient time also, but now the science, application science totally different. Why? Because time to time only basic science helps to make it very comfortable and application based science. So, this is the relevance. Without basic science, application science is not possible. Also complementary, when you say only talk about that basic science, but unless and otherwise it is not applicable, it is not applied, then there is no meaning of also basic science. So, we see that there is a very good strong relation between basic and applied science. So, it is important, it is also necessary also, sir.
If you could give some examples in today's context, that these are fundamental science studies and research, themes, topics, areas, domains, and these are what we would call applied sciences. So, if you could give some examples to illustrate the point, because many of our young boys and girls, men and women, the young adults who are listening would actually want to decide on higher education in sciences rather than just technology, based on this understanding of basic and applied science. If you could illustrate, sir.
Yes, sir. So, if we talk about say nowadays we are using mobile phone, it is very simple example, and it is so miniaturized, and we see that in a just with some say 1-2 centimeter dimension, we see that everything is there, available there. How is possible? So, this is technology part, that in a very simple SIM card and chip, we are just maintaining millions of data. So, only simple chip, small chip is sufficient to maintain all our big data. How possible? It comes from the basic science. One day, one person told that rooms at the level of nanoparticles. So, you see that the concept comes from theoretical aspect, basic science, that when material particles goes to the dimension of some nanometer range, then its property gets very peculiarly get differentiated.
Right.
And those properties is very applicable when we put this in the formation some chip level preparation. So, what we see, that chip device is now only possible unless and otherwise we do not have the knowledge of basic science for the nanoparticle, nano level knowledge. So, that basic science give us the room us for the product preparation in nanomaterial and devices. So, here a good example for the basic science and application science also.
Very good. Some similar examples, if not getting into detailing of it. So, these are studies of basic science, and these are the applications, if you could come out with, from all fields, mathematics, chemistry, psychology, physics, from any field like.
Okay. So, just if we give the example, say some physics here. So, there the basic science is there, how the particles behave when they come closer to each other in many particles, then their behavior only explained with the basic science and physics also. So, this is the basic science, and when we go, so there is the preparations of some smart material. So, for example, automatically when temperature just a very cold time, but the material will behave just like it will absorb the heat and maintain the atmosphere very hot. So, this application of material science is the application based. So, if we just divide this into two domains, the material scientist, material science is application based,
Right.
but the condensed matter physics is the basic science. So, we see in two form, condensed matter physics or solid state physics is the basic science, and material science is the application based.
Right.
So, basically this is the product of
Very
physics.
good example. Very good example, sir. Yes,
Yes.
please continue. Yeah.
And for say physics, even if we say, for example, chemistry, say nowadays we are talking about the molecular docking. So, I give very good example now, the COVID situation. We are finding the different method that how this just coronavirus molecule can be just ruined and can be just stopped for their functioning. Then chemistry comes. One chemistry say this is the chemistry of say guest host chemistry. What does it mean? Total theoretical. Means that some molecule formation outside and inside another molecule will sit among this cage like, and then they will behave just like some relationship prepared between these two. This is the one type of special type of molecule, guest host molecule. So, this is totally theoretical chemistry. When we apply this, then comes to molecular biology. There in chemistry we apply this principle. Now we are talking about this kind of enzyme preparation, some kind of even frankly speaking, just a few days back we have just organized one just webinar given by the Nobel laureate Professor Len. That he given also a very good his example, his work, that there the application based some chemistry is there described. It is, he told that he was working on the preparation production of vitamin B12 molecule, but this is the application based, but this comes from the chemistry of guest host chemistry. So, this is guest host chemistry is the theoretical part, basic science, and the molecule preparations of vitamin B12 is application science. So, everywhere we see like in this way the basic science and application science, two domains are there.
Very well explained with multiple illustrations and examples, and this is young men and women who are listening. This is an important part to understand while you study sciences, particularly at university level, and if you are keen to study sciences at bachelor's and master's level and go into applied science or go into research or whatever, this is a significant point of distinction. This is a significant point of knowledge that you need to understand and comprehend and apply. Going ahead, sir, the 21st century has dawned with a lot of possibilities in sciences ahead and their applications both. So, would you identify, I understand the growth of science is not a matter of few days, few years or things like that. It's over decades and centuries that sciences grew. Having told that, what are the significant trends and approaches that's happening in basic and applied sciences today in the 21st century? If there are 3 or 4 outstanding points that you have to identify, what would you do so?
Yes, sir. Actually, this 21st century is going to become the century of, rather I should say, biological science. But biology, this is little bit now very broad sense, and it becomes some interdisciplinary work which involves the science from physical science, from chemical science, and supported by biological science. And frankly speaking, now I believe that the demarcation as biological science is no more. Their application comes from physics, chemistry, and also mathematics. These 3 components are very important to know about the biological system. So, this century what is being going on very remarkable for biological science, this standing based on 3 science: physical science, chemical science, and mathematical science. How? The explanation will come in this way. I give one very specific example. We are in very crucial moment now. Everybody were running behind to find some remedy against the coronavirus. The coronavirus, this viral molecule, actually when goes to body, human body cell, they interact there. Basically, they are reacting with the cell molecule and they ruin the cell molecule. Now, to prevent this, people are thinking that where the point, if we strike that point of this molecule, then it cannot work. We can prohibit their action. Then comes the question, okay, we have to know the molecule of virus molecule, that where that point we can find. Then people start to think that, oh, then we have to see the molecular structure of this virus. If we want to see this, however, this simple naked eye is not at all possible to see this. How? We need some instrumentation, some equipment. Then comes the question, how it comes? Then it's simply the application of physical science.
Right.
For example, I am telling, say, one kind of very high intensity synchrotron light is used. Means that very high intensified beam, when fall on such kind of small molecule, they can show us the structure.
Right.
So that kind of beam light can be used. Now comes the question, how we can engineer this beam light so that we can explore the knowledge from such kind of molecule. So you see, here comes the concept of physics and engineering even. And why engineering? Then you have to put instrument in such a way we can get some optimization result. How it can be possible? Apply mathematics. So you see, both of application physics, mathematics is there. Then start, okay, if I put this light on the molecule, how the molecule react? How other molecule will just come close to it and it will react with this? Comes the question of chemistry.
Wow,
so
great.
Very interesting. We see that from very beginning, physics, mathematics, chemistry are able to find that position. I believe that time is very, very nearer. I am quite hopeful that that day is coming very soon, that these molecules are not very, what I say, a threat to us. We will overcome this. How? Then the application of these sciences, physics, physical science, rather, chemical science, mathematical science are doing this thing. So you see that this is the relevance that we should pay respect to basic science. Then only possible to apply this to go for the human being, mankind, also to restore the everything, the peaceful life of human being is possible.
Great. So at the highest level, all the natural sciences converge to solve problems of life or to understand life in a deeper manner. So this whole differentiation that we do is for the sake of our understanding of the subject, but in nature, in real life, they actually converge. To understand these three natural sciences that you have mentioned deeper, can we also talk about what are the specialization areas within physics, within chemistry, within mathematics, at least a few of them, and what do they mean? How are they different from one another?
Yes, sir. Actually, the 21st century, just what I told, going to be very remarkable for, say, for the human being, and the mankind civilization to be maintained, is necessary some very specific field of this physics, chemistry, mathematics. For example, in physics, if we see the different domain, then obviously material science, condensed matter physics very important. And number two, then high energy physics, particle physics also very important for such kind of exploration. And then another part also in physics, biophysics is going to be very more important also, because biophysics is not so simple something special from material science. Nothing but in material science they are using the unliving molecules, and in biological science they are dealing with the living molecule. Only thing is that now physics, when applicable to the non-living molecule, is under this kind of physics, that is condensed matter physics, high energy physics, particle physics, when this physics comes to deal with the molecule, living molecule, then comes biophysics. So, these are some specialization of the physics domain, and also obviously if we talk about some application based, there should come also other equipment instrumentation part also. It is also good contribution from physics. For example, say application, if we talk about say healthcare physics also in the different form, say some kind of medical instrumentation equipment, those are very important, those comes from also physics. So, these are some special domain of physics. Then go to chemistry. So, in chemistry, if we talk about nowadays very important part, we should know the molecular chemistry also, or molecular biology also. So, say specific some kind of chemistry, that is say biochemistry, molecular biology, and also some kind of say protein chemistry. So, these kind of fields are very important in chemistry also. Then if we go to other science, also mathematical science, they are very important task, that when we just take care very big data in different form, maybe in material science, maybe in chemistry, or maybe in social science, anywhere, then we need to handle big data. So, how possible? Mathematics may be possible to handle those big data. So, in that case, the big data science, the statistical science, the for example, some non-linear science, those may come under the also mathematics. So, these are some very specialized domain in science of this mathematics also.
Right.
So, these are some special domains.
Great. And when you bring in education in these natural sciences at Adamas University, are you looking at the specialization at the graduation level, post-graduation level? What are the different focuses on that? If you could speak on that.
Yeah. Sir, actually it is a very important also that when we just design the curriculum, keeping it in mind that there should be this specialization should be there, but obviously we have to see the level, whether it is UG level, undergraduate level, or PG, postgraduate level. In UG, first I am talking about UG level. In bachelor course, it is actually some bridge between the final 10+2 level school and then just going to the higher study in science. So, UG in that intermediate level. So, there we have to take care that if we go from very beginning specialization, then it may be some problem for the student to grab this one, because they are just coming from school level. So, there is some balances there. So, we do not put very specifically or exclusively specialization there, but some sense of specialization is there.
Right.
I give you one example.
Right.
Say for example, some students just starting UG level, say with say physics honors in BSc. So, already just it is a 3 years course. So, they have some the specific field. I do not say it is specialization, specific field. Why? So, for example, in say 3rd year, they have, for example, say quantum mechanics. Quantum mechanics is one just a domain in physics, but I should not say this as very specialization. Why? Because then student, they come from school, and if we give them as very specialized subject there, they maybe feel some problem. So, in that case, we start some very good just mediation from school level to just this higher education in a very soft way. Changing is there, so that student can learn some basic principle of quantum mechanics. At least this is quantum mechanics, they can know this one. So, in this way the curriculum is designed. So, for undergraduate level, even though some sense of specificity is there, but not is specialization.
Not in details.
Yes.
But and that is the right approach also. At undergraduate, they must be introduced to various specializations,
exactly,
niche areas, and postgraduate is to focus on them as such. So, sir, what at post graduation level of MSc, what are the focus areas of specialization in the various subjects?
Yeah. For example, one by one, just in physics, if we talk about, we have the specialization in, say, electronics, and then solid state physics or condensed matter physics, and then high energy physics. These are some specialization in physics. In chemistry, there are some specialization is there, physical chemistry, and then inorganic chemistry, organic chemistry, these are specialization there. And in mathematics, have some specialization in the field of data science and statistics, and also just computational aspect also. These are, and non-linear dynamics also there. So, and some kind of fluid mechanics, these are some specialization in mathematics. So, these are the specialization. And similarly, in other also domain, in geography they have some specialization also. In for example, in GIS, the geoinformatics is are there, and also some kind of environmental geography is there also.
Right.
So, these are some specialization in geography.
Psychology?
Psychology also specialization is there. I believe that say they have some kind of specialization on the, say, psychology of human indifferences is there, and then some kind of industrial psychology, and some kind of psychometry also.
Psychometry, okay.
These are some specialization in psychology.
So, having geography and psychology in the School of Basic and Applied Sciences, what is the rationale behind it, the thinking behind it of the university?
Oh, yes, sir. Sir, one by one I am telling, if we talk about geography, basically now geography is not same as, say, 20 years before when we just study, say, geography. That time geography means that in our mind some map is there, this is the state West Bengal, here Uttar Pradesh like this. But now geography is not simple mapping. We have to see from top, where
human geography, social geography,
everything is there. It needs lot of expertise from science only. When you see remote control, simple application of physics there, because unless and otherwise we don't know the wave propagation, different just bandwidth also, then not possible to apply this remote sensing. So, this is the application of science. When we just go for analysis, simply mathematics, if we don't know the mathematics, we don't know the correlation, we don't know the regression, everything, then cannot just analyze the data, geographical data also.
Right.
So, there we need the concept of science, and in fact, what we are doing now, when students are coming, if they don't have science background or mathematics background, we put a crash course to them also to know about mathematics. Without mathematics science, not possible to expertise in geography. So, we see that even though geography is geography, but it is based on science. Without science, geography is not possible at all. This is geography. If we talk about psychology, it is also very relevant that why it should be in science. I have
because
seen
some universities have kept it in humanities as well.
Yes.
Like going on.
Yeah. If you see the curriculum, then it is very easily understandable that more than 60% inclined to science, and 40% maybe to social science, something like this. How? I give one example. So, for example, say brain psychology or neurology part. So, if you want to know the abnormal condition of psychological state of human being, then one should know how the central control system is working there in brain. Then you may ask, so it comes under biological science, right? But when if you see the computational effect in brain, then we need lot of information from mathematics, from physics, from chemistry also. Otherwise, you cannot be very good expertise on psychology. It is one example. Next, say for example, you are studying some data, some macroscopically some data, you are studying that some vulnerability of the just a psychological effect, something this thing. If you want to study this one, I believe that it is only possible if you handle very big data. Simple 100 data is not sufficient to go for some hypothesis to be established. So, when you handle this big amount of data, where other science, only mathematical science is possible to do this one. So, really if you do something very special, then without science, psychology is not perfect, is not complete. This is my understanding. I believe that. Also, it is nothing but a science to read the human mind. So, science is there. So, science is totally supporting the psychology. So, these are the relevance of psychology to be in science background much.
Great. Sir, if you could also speak about the school itself. For example, the school, first of all, from School of Sciences, it has evolved into School of Basic and Applied Sciences. Very interesting. To an extent, you have differentiated very well between basic and applied. But this change of nomenclature surely is a change of philosophy. If you could speak about that. And secondly, how equipped is the school with respect to infrastructure and high quality faculty members, and how are you dealing with the education of sciences, both basic and applied, differently or uniquely in comparison to similar other university departments in our vicinity, particularly East and Northeast India. So, the philosophy in the nomenclature change and the USPs of the school, including infrastructure and faculty members. Over to you, sir.
Sir, it is very relevant question that previously the school was named as School of Science. Then it was realized that just already we explained these things, that simple science doesn't mean the exact also way of activity there also. The school basically dealing with both prototype science and application based. It is something like this. So, one sphere, the inside center is prototype science, around this the whole sphere is covered by some application based subjects. So, if it is so, then we should have very proper communication and understanding between basic science and applied science, to make it clear, to make it interpretive, better to give the name school as the basic and applied sciences comes from this. This is the philosophy, so that people get motivated, people get encouraged to do work, and really some sense of interdisciplinary work may be done. Based on this thinking, the name of the school is given very rightly, the basic and applied sciences. So, this is the philosophy. Philosophy is that to correlate between the basic and applied sciences, number one. Number two, to get the motivation, and number three, to encourage people to do work in an interdisciplinary way.
Very good.
These are the points.
The rationale behind it.
Yes.
So, infrastructure, faculty members, unique positions or unique aspects.
Yes, sir. Infrastructure, really I am proud of a member of this school, because I welcome everybody to see our school and labs also. We are following the UC given CBCS, that is choice based credit system, and which means that student, the learner can take the subjects as per their choice. So, really to implement this, the necessity is to establish very good infrastructure of laboratory first. Why? I am giving one example. Say one student in physics honors, he wants that I would take some subject from biotechnology. He can take this. This is the concept of CBCS. So, you see that by the side of physics lab, we need to establish another lab also. It is under other school even though. For example, I am talking about some psychology student. He wants that I want to know some physics principle. So, he just choose some course or some lab from physics. So, as per his or her requirement, we have to establish the physics lab also. So, you see that this kind of course needs a big infrastructure establishment of lab. We are really very happy that we have such kind of apparatus equipments in our lab. Even I give one just one quotation, sir. Just once UGC just evaluators went to our university campus, they were really very happy to see our physics chemistry lab, and they told that what we see here, the instruments, equipments in the lab is really very nice, and other institute also can follow this, just this statement you see. So, I think this is sufficient to express that regarding our lab infrastructure. Not only that, in our lab we are running at this moment 8 DST or SERB or other government funding agency projects. So, these projects basically just establish very good research atmosphere labs also there. Now, question may comes, these are from DST or research work, how it help the student? I am telling that, say some students, they have some specialization, they can use say in time when available to work in that lab also.
Very nice.
So, in this way we are just technology transferring to them also, and they can be equipped with very modern concept also.
No, that undoubtedly, I mean the coexistence also of School of Basic and Applied Sciences, School of Life Sciences and Biotechnology, School of Pharmaceutical Technology and School of Engineering and Technology. All these 4 in one campus, in a large beautiful 120 acres plus campus, and with almost, if I am not wrong, around 130 faculty in all of these areas together, faculty members, more than half of whom are PhD holders, a fabulous sort of an environment for learning sciences. Undoubtedly, sciences from its fundamental areas, sciences from its applied areas, from its technological aspects and various areas that you are covering. It's a fabulous work, and as you said, it's a matter of pride to belong to such a fraternity, such a campus which deals with these technologies and all. Sir, if you could speak on the research ecosystem that you have created, research environment, how many PhD students or learners are there, how many patents are there, or how many higher postdoc work is being going on, or what research associations you have with universities abroad. If you could speak on those areas.
Yes, sir. Really, if we should not speak about the research aspect of our school, it is not proper also, because one important and to be proud, the component is research in our school. If we talk about the strength of our faculty members doing research, 95% of the faculty members are PhD holders.
Very nice. 95%, as good as 100%. I mean, maybe 1 or 2 only, and they must be on the final stage of their PhD.
Exactly, exactly.
Great.
And many of them, they are trained from foreign universities also in postdoc fellowship or research work. So, they are equipped with modern science technology also, how to do research. Already this experience is there. So, this is the quality of the faculty members. Then, if we talk about the obviously, when you go for research, not only faculty member, we need also PhD scholar. In our school at this moment, we have around 15 PhD scholars, and in different fields. So, they are attached with the faculty members guide, they are doing work, and in a regular way the research is being going on. Number 3, we have some collaboration with also foreign universities, lab, nationally reputed or internationally reputed labs also. I give one example. We have one just agreement with Slovak Academy of Science,
Great.
Slovak University of Technology, and in fact also in a fellowship the faculty member also joining there, in a visiting position they are attending there also, and some exchange program is there. And maybe next year we are just sending some students also with fellowship to do some work with them also. So, some exchange of research is being going on also in this way. So, these are there some collaborative work is being going on, and this is internationally. Even nationally also with very big premier institute also we are doing work, which includes IITs, ISER, and also other premier institute also. How? Because it is some kind of supplemented by the project work, internship work is being going on, and in association, in a collaboration is work is being going on. So, we are at par the national level also in this way that we are doing research work. Now, question comes, what is the product ultimately, output? We are very happy that the last 1 year we have published more than 34 just articles in very reputed indexed SOBAS index journal also, SCI journal also. So, these are the outputs.
35 in 1 year.
In 1 year.
Very good. Okay.
So, now we are trying to
just is almost 3 a month, 3 SOBAS indexed a month, almost 1 a week. I mean, if you can push the standard a bit more, it will be 1 SOBAS indexed article by someone in your family, in your school every week, and that could be the goal for the next 1 year again.
We are trying, sir, and we are very happy that management, all of you just give us the support, and obviously we will be happy, and your support is more important.
As reputed schools dean here, you are a part of the management as well, and it is collective work of all of the leadership with support from our entire team that whatever we are achieving. So, but it's really a matter of pride. I do not know many new universities which are less than 6 years old, or which we are in the 6th year running, would have one single school, the School of Sciences, Basic and Applied Sciences, who are producing 35 SOBAS indexed in-depth academic journals in one single year. That's really appreciable. Yes, sir. Go ahead, sir.
Sir, and then also we have some patent. Even though it is it should to be increased more, but some patent is going on, and then we are just regularly organizing different scholarly activities, which includes the really not very light but very heavyweight, some workshop, conference, seminars, and they are very famous and very established scientists coming, and student have very big scope to interact with them also, because we believe that only the knowledge confined in book is not sufficient. So, unless and otherwise the translational research comes to the mind, and this kind
I really appreciate transnational research. Please explain for the sake of the viewers.
Some translational research.
Translational, sorry.
Okay. Means that not only confined that only we are doing work only for the publication, not that. How that can be translated for the profit of the human being and can be applied for the betterment, for the well-beingness. If research transforms or translated to that part, that activity, then this research is really helpful and productive. So, we are give emphasis on this also. I give you one example, sir. For example, we have one very good excellence center for the pollution just measurement. Those is there. We have very sophisticated instrumented. We have one instrument known as atomic absorption spectrophotometer. So, which help us to take the data regarding the pollution in water, in soil, everything in the locality. So, it help us to do this work. So, we are doing this kind of also just outreach program, also with locality some program. We are taking data, we are measuring, for example, different places how the concentration of arsenic, those things here. We are taking data geographically. We are also doing this work in association with the chemistry, geography, and the other department. We are analyzing this data. So, translational research is that not only we are talking about the the process or working principle of that instrument and how it is applicable. We have done this work and paper published, not that. Really, we put some input to know about the real problem to solve this one. So when it comes to that level, it is very effective, it is very productive. This kind of work also we are giving much emphasis on this also.
That's indeed a new concept I have learned. Thank you for that. Sitting in this chair, anchoring interviews one after another of the leaders of education allows me to learn a few concepts every day. And I'm really thankful to the gurus of education for doing that. And I'm sure the members of the audience, whoever is watching it, whenever this shall be taken to a large number of youngsters through various means, Chetana TV or YouTube, and also through WhatsApp links of the YouTubes to thousands of students, they would all be learning these new concepts as we go. The last question, sir, what is the future of sciences? I mean, that's a very in a way vague and too large a question, but still, what is the future of sciences and its education, and particularly you personally and your school, what are you planning to do in the next, let's say, 1 year from now, 1 to 1.5 years?
Yes.
So your domain and your team's initiatives over the next, and possibilities over the next 1 to 1.5 years, let's say till 2021 end, if you could speak on that.
Sir, this is my final one conclusive word. I should say the problem which we are facing in different aspect, different domain, cannot be solved based on religion.
Very nice.
Based on some superstition, based on some kind
That's a scientist speaking, right?
Yeah.
Yes, sir.
Only possible to solve this based on science. Science is only way to solve the problem, to know the problem. Solution may come, may not come, takes time, but only the problem can be understandable with the help of science only. So without science, nothing possible to be solved. And finally, give one quotation, two very great persons' quotation I should share here. One person from literature told, "Mohabishye mohakale mohakasho majhe." The Tagore, that quotation means that this universe unlimited,
Right.
time unlimited, everything, space is unlimited. The same thing told by Einstein, physicist, that space, time, mass. Same thing. So you see that literature, science, everything come to the same point ultimately to know about the problem. So I believe that science is only the way to know the problem at least, then go for the solution. So here is science, sir.
What a beautiful way to end this interview, where the left and the right brain have come together, where literature, philosophy and sciences have merged at a certain point. And that's what reality is about. When we learn something, we may learn it into watertight boxes at times. You may learn into specialized or classified situation or classified nomenclatures at times. But at the higher level of learning, higher level of comprehension, understanding of civilization, understanding of nature, they all merge together. In a very beautiful, with multiple examples, Dr. Sarkar has explained to us the relationship and yet the differences between basic sciences and applied sciences. He has spoken about very niche areas within the domain of sciences. He has also spoken about natural sciences and applied sciences in the form of psychology and geography, how they are today in the domain of the School of Basic and Applied Sciences. He has also spoken about research environment in general in the country and with specific reference to his school. Yes, young ladies and gentlemen who are out there, who love sciences, who have been studying with lot of passion sciences, for them you have a great opportunity to study in the School of Basic and Applied Sciences, Adamas University, Kolkata. Very rich, 97% PhD holder faculty members, only 2 or 3 remaining, and they are also in the final stage of research. Very rich also from the point of view of translational research, interdisciplinary research, application oriented research, and that leading to so much of Scopus indexed so many Scopus indexed articles, and as well patents as we go ahead. And youngsters can join the corporate, can join academics, can join research bodies, research labs as you pass out. So a big possibility. You are welcome to study it further, explore it further. Thank you, Professor Bimal Sarkar, for your takings from various angles, from philosophy to till the end that you have brought in, and I really liked the way you brought this whole discussion to an end, and I hope you will keep steering the leadership of the Sciences School to higher heights, greater heights in times to come. Thank you, and
sir.
Thanks to all the viewers.
Itu